Welcome to General Calculus. It is very possible that this is your first math class in quite some time, but we are here to help you with the background and intuition you need to thrive in this subject. This video series will loosely follow the structure of James Stewart's Calculus Early Transcendentals. In this video, we will give a preview of calculus before we dive into the first chapter on functions and models. Calculus will be fairly different from your previous math courses. While you will need to use many of the tools you have learned in your algebra and geometry classes, such as solving for variables, writing equations for lines, and graphing functions, calculus introduces new lines of reasoning to better describe the world around us. It deals with rates of change for functions that describe more than just straight lines, as well as how to go the other direction and use rate of change to describe what has happened over time. Here, we give a couple of examples of how calculus arises naturally in our everyday lives.
Okay, so to get an idea about how calculus is quite different than the math that you've likely encountered before, let's take an example. Probably an example that you're somewhat familiar with. Let's say that Liz and I take a road trip from Kansas City, Missouri to Boulder, Colorado, which is a 600-mile drive. If I told you that the drive took us 10 hours, you'll be able to calculate our average speed using your favorite type of math, algebra. Well, speed is distance over time, so our average speed was 600 miles divided by 10 hours, or 60 miles per hour. But that is not the whole story, right? I mean, we probably weren't going at 60 miles an hour the entire trip. There must have been traffic lights, and stop signs, and roads with different speed limits, and you know that I probably needed a bathroom break somewhere along the trip. So, how can we get the whole story? How fast we were going at a particular point in time? That is precisely where calculus comes into play.
Here's an example of what a graph of distance traveled versus time could look like. Time is on the x-axis, and distance is on the y-axis. The origin represents the starting point in Kansas City, and the end of the graph represents our destination, Boulder. As Tatsu said earlier, the average speed is 60 miles an hour. It turns out that when we're looking at a graph like this, you're essentially looking at the straight line connecting our start and our endpoints, and then saying that it has a slope of 60 miles an hour. But if we want to know our speed at a specific point in time, say here, or even here, we need to know about the slope at each of these individual locations, which is something that we can use calculus to find.
Now, if you give me the opposite information, like about how fast you were going at what time, and let's say that you now want to figure out how far you've traveled. You know, this is easy when you go the same speed the whole way. Once again, algebra can help you figure that one out. But you can see how quickly it becomes complicated when you introduce changes in speed. Solving this complicated problem is yet another task calculus can help us accomplish. And that's not the end of it. In addition to the physical sciences, calculus is used extensively in the biological sciences, human sciences, business, economics, and in analyzing pretty much any graph that you've ever seen in your life. So in this video, we talked about how calculus is quite different than the math that you've likely encountered before, and we took the specific example of a road trip to show you how calculus can help us determine speeds at particular points in time when you have complicated changes in distance, or the other way around, to calculate distances at a particular point in time when there are complicated changes in speed involved. So with that, we'll see you next time when we will begin to talk about functions and models.